Hello everyone, welcome back to BC Calculus. We're in lesson 15 and we're talking about derivatives of trig functions. In this video, we're going to do a little randomness. We're going to talk about chain rule for trig functions. Again, another definition of the derivative, a particle motion question, and an implicit question. So we got a lot of stuff to go over just because we're now doing everything we've done in the previous lessons just with trig functions. So I'd like to start with question number 10. Because if you guys look at these two problems, they look very similar. But the first one is just the sine and the theta. The theta is actually x squared. So for question A, theta is equal to x squared, and our function is just going to be the sine of that theta, right? However, for B, our theta is going to be equal to x, and our function is actually going to be equal to sine of theta quantity squared. So if we look at these two problems, they're done in two completely different ways. So we talked about in the first video that when you're taking the derivative of a trig function with a theta, your eye only looks at the trig function first. So I want to find the derivative of sine, which is cosine, and I'm going to leave theta alone, and then I want to multiply by the derivative of my theta. So I'm going to multiply by the derivative of x squared, which is going to be 2x. So our first derivative, so our a is going to be equal to 2x cosine of x squared. Do not be surprised to ask for a second derivative here, where you would then have to use the product rule and the chain rule. And we did one very similar to this in the very first video, is example number 1. So just putting that out there to you guys, just to make sure that you may see that eventually again. For question B, I want to use the chain rule here. So the derivative of sine squared x is not cosine squared x. You have to be able to rewrite this as sine theta, or in this case sine of x. So let's rewrite this in the context of the problem. So we're going to write the sine of x all raised to the second power. So you're going to use the chain rule for this problem. So this derivative is going to be, I'm going to pull the 2 down, I'm going to leave everything inside the parentheses alone, and then I'm going to multiply by the derivative of what's inside of the parentheses, which is going to give you cosine of x. So you guys can see that this is the correct derivative for this function. However, you should also know that this is an identity. We talked about identity in the first video. This is identity for sine of 2x. So both of these are correct answers. But knowing the double angles are really helpful for these particular questions. Because if I asked you guys, if I wanted you to find the derivative of, if I gave you the function y equals 2 sine x cosine x, you could find the derivative by using the product rule or rewriting this as sine of 2x and then just find the derivative using the product rule. Using the chain rule. So the derivative of 2 sine x cosine x would be equal to, so this derivative would be equal to cosine of 2x simply times 2. And if you guys do it with the product rule, you're going to get cosine squared x minus sine squared x, which actually is the identity for cosine of 2x. So those two identities are really helpful in these particular problems. So the double angles, the Pythagorean ones, are really helpful. The half angles we will get to much later in the course. So they're coming, but not that much right now. All right, so for this question okay, so what I really want you guys to do, and I'm going to keep stressing this a lot, is please, please, please rewrite your function. So cosine of x cubed all raised to the second power. Because now we obviously can see the chain rule here. So just like before, we want to say that the sine squared of x is not cosine squared. So if we rewrite it, we can see that when we pull the 2 down, we have to leave inside the parentheses alone. So when we see this problem right here, we're going to pull the 2 down, and then we're going to leave everything inside of the parentheses alone to the 1 less power. So our attention is just on the outside 2, and again, we now have our attention go to here. Well, just like in this example with this one, the derivative of cosine of x cubed is going to be, well, again, because the cosine starts with a c, we're going to change the sign, so it's going to be negative sine of x cubed. So again, take the derivative of the trig function, leave theta alone, and then finally our attention goes to our theta, just like over here, and we're going to take the derivative of that. We're going to get 3x squared. And so we can look at, we have a 3x squared, we have a 2, and don't forget about our negative. So we have a negative 2 times 3 is 6x squared, so a negative 6x squared, and then we have a sine of x cubed, and then we have a cosine of x cubed. So our answer here is going to be C. Our answer is going to be C. So in the previous video, we did a limit definition of the derivative, and that's exactly what you see here. The only difference with this problem is we are now actually asked to evaluate it at a value. So in this particular example, we're looking at A being our pi over 4, and then I told you guys put a big ol' X everywhere you see something with a value and an H, and so our function is going to be just tangent of X. And so all we need to do to find this limit is take the derivative of our tangent of x and then plug in pi over 4. And again, you know you got the right function and the right value for a, because if I plug in pi over 4 to tangent, I get that value here as 1. So we know that we're on the right path with that. So our derivative is going to be equal to secant squared of x. And then we want to evaluate that at pi over 4. So I get the secant squared of pi over 4. And an easy way to do this without a calculator is know that secant is the same thing as cosine, well, the reciprocal of cosine. And so remember that the cosine is going to be 1 over the square root of 2. And so that means secant would be the square root of 2. And so when you take the square root of 2 and you square it, you're going to get 2. So this limit is equal to 2. Okay, so now we're going to go up to this fun calculator question. It says question number 7. Again, it's particle motion. You've seen this before, but you haven't seen it quite like this one. So this is definitely a calculator question. And it says a particle moves along a line so that at time equals t, where we're in the interval from 0 to pi, the position is given by -4 cosine of t minus 1/2 t squared plus 10. What is the velocity of the particle, so the derivative of this, when the acceleration is equal to 0? So we have to figure out what time they're asking us for. We need to know that. So what we must do, first of all, is find the derivative. So set our velocity, find the derivative of this. And so again, the derivative of, I actually haven't talked about this yet, but a derivative of a constant times a trig function is just going to be the constant times the derivative of the trig function. And if you did the product rule, and again, I'm saving time here, but if you do the product rule with this, you would see that, you do the first times the derivative of the second plus the second, and then the derivative of the constant is always 0. So that second part doesn't matter. So that's why you can always just take the constant, plop it down, and then take the derivative of your trig function. So we get the derivative of -4 cosine of t is +4 sine of t. And then this is going to be negative. And remember, it's going to be 1/2 t to the second. So you're going to move the 2 down, and the 2's are going to cancel. So you're going to get t to the first power, and then the derivative of 10 is just going to be 0. So let's rewrite this a little bit nicer for us. So we're going to get 4 sine of t minus t. Okay, so that's our velocity function. Now if I want to find the acceleration, and I want to set this equal to 0, right? I want to find the acceleration and set it equal to 0. Well, that's the derivative of this. So we're going to get 4 cosine of t minus 1. And so we're going to, again, set that equal to 0. So we're going to get 4 cosine of t is equal to 1. Then the cosine of t is equal to 1/4. And then we're going to use our calculator, and we're going to do the inverse cosine of 1/4. And we're going to figure out what that is. So we have our handy calculator that I'm going to turn on here, and oh bam, there it is. So it's going to be, and let me let you guys see, detach this. So when we do the inverse cosine of 1.4, we get 1.318. So time equals 1.318. And so all we have to do now is to use our calculator again and plug in 1.318 to our function. So we're going to get 4 sine of 1.318 minus 1.318, and you will get the answer is D. The answer in this case is D. Okay, so we've now done some chain rule, we've done particle motion, we've done the definition of the derivative, all this crazy stuff. So one of the last ones we're going to do in this video is our implicit. So we have two more questions we're going to do, and they're both implicit questions. So question 5 says find y prime if sine of theta being x plus y is equal to y squared cosine of x. So we like this question a lot because it does a lot of good properties with it. So we're going to take the derivative of the left side, which again is a trig function and a theta. So like I've said many times before, we only care about now about the trig function, and then we're going to leave theta alone. So it's just going to be the cosine of x plus y, and now we're going to multiply by the derivative of our theta. Well, the derivative of x is simply going to be 1, and then our y is going to be dy dx. And so that's the correct way of doing this. And we're not going to distribute this per se right now. We're just going to leave it alone for a second. And then on the other side, we're going to use the product rule, right? We have the function y squared and cosine of x. So we're going to do the first, and then we're going to multiply by the derivative of cosine, which again, because it is a negative, because it begins with a c, it's negative, right? So it's going to be y squared times negative sine of x. So it's the first times the derivative of the second, plus the second times the derivative of the first. And again, just like before, we have 2y and then dy dx, right? dy dx. So if we were to distribute this, because this question is looking pretty nasty now that I'm seeing it, but we have a dy dx over here, and we can go ahead and distribute this. And so let me do that now. So I went ahead and distribute this. So we have two terms here that have a dy dx on them. And I'm going to go ahead and move this over here because there's a negative in it. So I'm going to get cosine of x plus y plus y squared sine of x. And then I'm going to get 2y cosine of x dy dx minus cosine of x plus y dy dx. So once we have implicitly differentiated, we have two terms. Once I distribute the cosine of x plus y, two terms. So just like in the previous examples, we go ahead and isolate. And just up here in the top, we're going to go ahead and start simplifying. So we're going to get cosine of x plus y squared sine of x. And then I'm going to undistribute my dy dx on the right side. And I get 2y cosine of x minus cosine of x plus y, which is crazy. And so our answer is going to simply be, and I'm just going to move this over here, it's going to be 2y cosine of x minus cosine of x plus y. So is that the prettiest answer? No, but that is the answer. That's the answer that we got for this problem. And so that is what we have to do. So like I said, it's not the best question. It's not something that I would think it would be deemed testable, but I do think it's good just to remember to find the derivative of something like this, where you have to find the derivative of the trig function and the theta, and then also using the product rule. So if you guys got it in you, got one more question here. It says find the equation of the tangent line and the normal line to this curve. So let's go ahead and look at it. And we're going to start implicitly differentiating. So the first part is going to be y cubed. So the derivative of that's just going to be 3y squared. And again, because we took the derivative of a y function, we're going to do dy over dx. This is where it gets a little bit painful because we're going to use the product rule here. But we have a strategy for this question, why it's on there. So don't worry too much about it right this second. But let's go ahead and find the derivatives because that's what we need to do here. So we use the product rule. So we're going to do the first. And then we're going to do the derivative of the second, which again would be y squared is 2y dy dx. And then we're going to do the second, plus, and then we're going to do the second times the derivative of the first. All right. And notice that I put a big bracket because both these things are going to be subtracted. Okay, so please make sure that both of these things are going to be subtracted because we're subtracting the whole thing right here. And now we get to the derivative of cosine of xy. And just remember that the derivative of cosine times theta, or of theta, we just leave theta alone for a second. So it's going to be minus sine, and then we're going to leave theta alone. And then we're going to multiply this term by, again, using the product rule, the first, times the derivative of y, plus y, times the derivative of x. And that's going to be equal to 0. Now, why is this so important? Well, that was crazy, right? That's absolutely insane. We got to figure out what dy dx is. But one of our saving graces is that x is actually equal to 0. So if you look at this, this has an x in it, right? We're multiplying x times this. So that term's going to go away. And then what's actually really awesome about this whole thing right here is if we plug in x for 0, then we're going to get the sine of 0. The sine of 0 is 0. So this whole thing goes away. So all we're left with is 3y squared dy dx minus y squared is equal to 0. So all that crazy derivative stuff, that nightmare, actually turned into something pretty easy. And then all we have to do to find y is come over here to our original and do y cubed, right? So again, x is 0, so this term's going to go away, plus cosine of xy. Well, we plug in 0 here, we're going to get cosine of 0, which is 1, is going to be equal to 2. So y cubed is going to be equal to 1. So y is actually equal to positive 1. So then we plug back into here and we get 3 dy dx minus 1 is equal to 0. And so dy dx is going to be equal to 1 over 3. So this is going to be the equation of the slope of the tangent line. So this is our tangent line one. So I'll go ahead and write this in orange. So our tangent line is going to be y minus 1, and then it's going to be 1/3 x minus 0. So this is going to be the equation. So again, kind of atrocious question to start with, but it ends up being pretty decent, pretty nice for us to do for these particular questions. And then in brown, I'll do the normal line. And the normal line, again, is just the perpendicular to the tangent line. So it's the same problem. It's going to be y minus 1, but instead of being 1/3, the reciprocal of that's going to be negative 3 x minus 0. So those are your answers for this. And so that's a lot of questions for this particular example for derivatives of trig functions. So we'll come back in the next video and we're still talking about triangles and how to talk about inverse trig stuff. So I'll see you guys in the next video.